Hey, Miami. Hey, my battalion, Dinesh. Good morning.
Good morning, sir.
Yes. Good morning, sir.
Sorry for last week. Actually, there was some emergency and I have to cancel the class, but we'll try to continue from this week onward. Okay. All right. So let me share my screen and we can start. We can continue the session. Just give me 1 second. Just 1 minute more. All right. So we all good. And let me share my screen. And I hope last week we had a very good discussion. Not last week, last to last week, we had a very good discussion about the HSRP. And I just did configuration, did the detailed discussion about the HSRP. So definitely I will do the VRRP as well later on. But before I do the VRRP, I will just do the some discussion about this architecture because I will do the configuration later on. But let's understand some important topic like SSO, right? We understand the FHRP and we discuss the detail about the configuration as well, how the HSRP is going to be configured, what is the key component of HSRP, message type. Even we understand about the 𝗁𝗂 𝗂𝗃, we understand about the how we can do the like failover in case of the HSRP we are running, how a preemption is going to be configured, how we can configure the tracking even. If we want to do the tracking configuration, then how tracking is going to be configuration in case of the any failover based on the interface tracking, based on the IPSL tracking. So these all things we understand, and I hope you guys are very much comfortable on that. Okay. So now what I'm going to discuss, the one topic left in this first module, not first module, first sub module, that is the different type of design principles. So SSO, what is SSO? So SSO is basically a very small topic, but very important. SSO is basically known as the stateful switchover. Let me use the pen as well here. This SSO is known as the stateful, sorry, right. This is the full form of the SSO. So why it is important? So basically it's similar to the high availability. You can just think about the high availability, right? HA, and it's going to give you the zero downtime in case of the device is down. Means earlier, my two routers I just place in the group, HSRP group. One is going to be down, then another is going to keep the redundancy. Similar SSO, let's suppose I have a single router, okay, and router having the route processor, RP. And if RP is going to be down, then what is going to be happen? My entire router is going to be down. Simple. So instead of one RP within the router, I can place RP2 as well. Okay. So if I going to place RP2, then what is going to be happen? In that case, if any RP is going to fail within the router, so my another RP is going to take role, that is the SSO. So how the design is going to happen? So HSRP like R1, R2, they are connected in the LAN, right? This LAN, let's suppose this is connected by this way, and we have the PC and we have the internet. They connected. So in case of the HSRP or VRRP, if you are running that, if my link is going to be down, failover is going to be happen. This link is going to down, failover is going to happen. This router is going to be down, then again failover is going to happen. But let's suppose router is not going down, but their route processor is going to be down. So entire router is going to be technically down. So if we having just only one route processor, which responsibility is to process the route, then my failover must be going to be happen. But what if I have a two route processor, RP1 and RP2? Then in case even my one RP is going to be down, another is going to be serve my all requirement. In that case, still my this traffic is going via the primary router until my second RP is going to be down or complete router is going to be down. This is the role of the SSO, that is known as the stateful, right, switchover. That's going to maintain, that is your session continue in case of the any kind of the RP is going to fail. So there is a two kind of the route processor is going to be there in the routers. One is known as the active supervisor Niyami, can you just Niyami, can you just mute yourself? Niyami?
রাত 8টা থেকে বৃষ্টি হচ্ছে
Niyami?
তো তোমরা তাহলে
So there is a one is going to be there, hold on. This should be okay. Let me write again. So one is why I'm not able to write. Sorry, guys. So one is active, right? Supervisor, and another is a standby supervisor. So in case of my active is going to be down, that is going to be standby is going to be take a role, and that is going to sub all your requirement, right? And what is the role of the supervisor in case of the any router? Even you have the multi-layer switches, and let's suppose you have 65,000 switches, 9K switches. They all are using the supervisor engine. Even the 4,500 switches, that is end of life, end of sale as well. So the supervisor is going to maintain the continuous sync of the routing table. That is the first thing. So they are going to responsible to maintain the routing table, and they're also going to take care of the ARP table, right? They also, this MAC table, you can just talk about MAC table is also going to be there, and they also maintain a session. Any active session you are running during that, all communications, that session table is going to maintain by this supervisor. So if any supervisor is going to down for any level, my failover is going to be happen on the second supervisor, and second supervisor is going to be give the immediate failover, right? So let me share one of the document as well. So it's a very small topic, but it's very important. Sometimes people ask that what is a SSO. So you can see SSO is the router with the hardware redundancy, and may have the dual power supply, that is giving the power supply level of the redundancy, and route processor is RPs. RP in charge of learning the network topology, creating the route tables. When it's failed, routing protocol adjacency reset, causing the packet loss and network disruptions. So SSO is going to give the alternate supervisor. Means if you have the two routers and and one router having a two supervisors, so immediately traffic is not going to fail or secondary router until my both supervisor is going to be down. So you have the automatic switchover between the supervisor, and that is the my soup engines basically going to be there. And probably if you have the, let me give some kind of the commands as well. There is a command as well, but probably, yeah, you can see. So you want to configure the there is show redundancy. It is going to give that all route. It's not going to be available for the all router, but let's suppose you have the ASR router, right? Very high end router, 7,000 series of router. Those router having the supervisor engines, and they are going to give the redundancy as well. So we can check the redundancy command as well, and they're going to give that all output. So this is about the SSO, and you should know about the SSO. It's a very small topic. And if you just go and search about it on the Google as well, what is SSO and Cisco networking? So you're going to see stateful switchover, high availability mechanism to minimize the network downtime during the primary supervisor engine route means is going to fail for the which is responsible for the route processor. And how it is going to work? The standby processors stay in constant communication with the active processor. If the primary fails, means both supervisor keep talking to each other. Like you can just think about the sync message, hello message. There is no such kind of a messages, but they still sync based on that communication. And in case of my primary is going to fail for certain region, then there is no traffic loss is going to happen. Immediately your passive is going to take a role, and it is going to be just give that all kind of the communication continuation, whatever you want to just do for the any kind of the communication LAN to internet. And if you want to check the commands, so in Cisco, all Cisco router doesn't support that, so but some of support that. So you can just run the command as I mentioned, so redundancy. So it is going to give that which is my active SOAP and which is my standby switch. So this command is going to always give. Because mute, guys, please mute yourself. I would request everyone, please mute. Please focus on the class, guys. If you have any questions, please ask me. Vikas Kumar Sinha. So redundancy stays, you can just, it is going to give that what is the state of redundancy as well, and synchronization detail also it is going to give that. And this is going to give RP01, RP2. And if you go for the Cisco routers and switch who have who support SSO. So you are going to get the model list as well. If you want to get the model list, you are going to get model list as well. So as I mentioned that, so at least 9,000s, you can see these 94,000, every 9K switches are going to support soup engines. So if you have this switch in your company, just run this command. So redundancy, it is going to give that all output of that particular redundancy details. And even for the routers, as I mentioned that ASR 1000, okay, ISR 4000 also, right? Cisco 12,000 means very high. As I mentioned that Cisco 76,000 series routers. So very high end routers means if you have the very high end router, they are going to support the SSO. Means lower end router doesn't have the dual supervisors. But if you go for the higher end router, those are going to support a dual supervisor. So you can just check if you have the company, if your company having this switch, this router, just try to run the command and try to verify that. Even if the go and WLC, that WLC also support 9800 series support and legacy 5500, 7500, 8500, 3500. So these are the SSO based devices. They have the dual supervisor. You can just think about the dual brain they have. And one brain is going to be dead, another brain is going to be take the role. That is the meaning of the SSO. Is it clear, guys? What is the meaning of the SSO? Just you have to understand theoretically what is the SSO. If any question, please let me know. It's very small discussion, but it's very important. Now, we have to move about the SD-WAN discussion. Okay. So we have to talk about SD-WAN. What is SD-WAN? How SD-WAN is going to work? Right? What is the role of the SD-WAN? What are different kind of the requirement we need to build the SD-WAN? So anyone in the class have the any idea about the SD-WAN? Any idea? Anyone in the class have the any idea about the SD-WAN? No
It-
idea?
It's a software definer like Cisco DNAC from where from the controller we onboarded the device and do the configuration, push the templates and all those things from the software.
Right, very good, Dinesh, very good. So, can you just elaborate, means how earlier WAN was working before SDN? Any idea? If there is no software, then how WAN is going to work?
Like we need to go we have to if we need to access any device remotely like SSH or telnet and do manual configuration like VLAN configuration, updating the switch firmware or doing manual configuration that could lead to manual error and all those things. But with this software defined
Mm.
access, we can do like avoid all those disadvantages, we can say, and you can push
Okay.
all those templates and everything in one go, which makes like, and also the it would be easier for like gives basically the centralized like you can have a look of all the device in one plane.
Wow, very nice, Dinesh. You have a very good idea. Okay. So anyway, thanks, Dinesh. I really appreciate. Anyone else want to say something about the SDN? Because we have to understand this is the future. Okay. If you don't know about this, you are not going to survive in the industry. So in CCNP, at least you should know the basic fundamental of the SDN technologies. We are talking about the SDN. SDN is known as a software-defined networking. These SDN have the three components, right? So you can see this is the SD access and SD-WAN also, right? Two things already there. And probably we are going to find three things also in the upcoming, might be here you're going to find. VXLAN and LIPS later on. So let me summarize. When you go and talk about the SDN, right? SDN is known as the software defined networking. Okay. So we have the earlier also networking. We are doing the routing, switching communications. Also, we have the data center communication, cloud communication. But before 2015 or 2016, that was earlier the plain communication of the networking. There was no software-defined networking. If I'm talking the plain, that means everything you're doing within the box. Means if you have to configure the router, you have to go inside the router and do the any kind of the configuration, troubleshooting, whatever you want to do that. You cannot do by sitting in some remote location. Means within the box, you have to perform any kind of activity. Means router have the control plane, a router have the data plane, and router have the management plane. Now we have to understand what is the control plane. Anyone know? Means if I talk router or switch. Come on, guys. Thoda sa you guys try to speak as well, okay? So I can understand. What is the
Brain,
control
sir,
plane?
is the brain of the router. We can say where when the router has to perform like routing, then it will check that.
Okay, so brain of router, right? So
Yeah.
control plane is like you can think about it's a complete intelligence system, nervous system of the any router switches. Without this brain, you cannot perform any kind of the things. If you want to do anything in your routing decision, packet forwarding decisions, brain is always going to require. Think in this way, let's suppose you feeling thirsty and you want to have a drink of water, means you want to drink one glass of water. So your brain is going to give instructions. Hey, you feeling the thirsty and you have to take a water. You have to drink the water. So brain have given instructions. Similarly, if any packet want to come and want to communicate from one source to another destinations, so router first will consult the brain. Hey brain, can you tell me how I can reach to particular destinations? Brain is going to be give the idea or give the decisions how you can forward the packet. That's all. Nothing more than that. So brain is nothing. Control plane is your brain, nervous system, and that is your routing tables. Means whatever routing table you have. What are routing tables we have? We have the OSPF, we have the BGP, and we have the 𝗂𝗪P static routing. These are basically going to build your brains. And based on these building blocks, you are going to forward the packet. So once again, I'm coming to the analogy. Means once you're feeling hungry or you're feeling thirsty, brain is going to give the instructions, but brain is cannot feed you. Okay. Brain cannot alone feed you. Means if you want to drink water, brain cannot, take water and put inside of your mouth. No, it's not going to happen like that. Your hand must act that. Okay. Hand is going to catch the glass, catch the food. Okay. Take the food, and that is going to fit inside of your mouth. So your hand is going to act as your data plane. Means data plane is actual plane where you are going to perform certain actions. You have to forward the packets. Okay. Means your hand is acting a data plane and that's carrying the glass inside of your mouse. That is your actual packet carrying, plane. That is your hand. Similarly, in routers or switch, we have the multiple interfaces. Just think about this is a switch or router. So they have the multiple interfaces, and might be one interface is going to connect with one PC that having a subnet 10.10.10.10/24, and another PC is connected with the another interface. Think about this one. This having a subnet 172.16.10.10./24, right? They all are going to connect with the brain. That is the nervous systems, right? So whenever this packet is going to punt on this interface, just think about this is the gig 0x0 interface, and this is my gig 0x5 interface. So whenever packet is going to punt on this interface, so they are going to have a two field. The first field having the source IP, second field having the destination IP. So what is my source IP? Source is going to be 10.10.10 and destination is going to be 172.16.10.10. So my packet is going to punt, means it is going to hit to this particular interface. This interface is going to consult to the brain. Hey brain, Can you tell how can reach to this destination? Because routing always happen based on the destination IP address. So this packet is going to punt to the brain. Brain is going to be single point of contact who is going to guide you how you can reach to particular destination. So brain is your nothing, it's your routing table. So they are going to consult your routing table, and this routing table is known as the control plane. Okay, so packet is hitting this interface that you're receiving the actual data. So that is known as a data plane. Okay, this all interface is part of data plane. This is also data plane. Clear? So means you're receiving the actual payload, actual data. Let's suppose you're sending the any video file. Video file might be you want to say your photographs. So photographs always going to be communicate from one device to another device based on the IP address, logical address. IP is always known as a logical address. So packet is going to punt. This interface going to consult to nervous system brain. Can you just tell them how to reach? Then it is going to guide you. Yes, you want to send, you can just use this interface. Then your packet is going to transmit it to this one. So this plane is who actually transmitting and receiving the packet, either transmit the packet or receive the packet. In both case, it is known as the data plane. Clear? Give me thumbs up, guys, if you everyone understand the difference between the control plane and data plane. I hope this is clear, right? Now, what is a management plane? Management plane is just, plane actually technically in a single router and single switch is part of the control plane. By using any single IP address or might be multiple IP address, you just doing the management of the box. Means you're taking the remote access of the box. You're doing the config of the box, right? Means router basically. And you can doing any troubleshooting. So that is a management, means you connecting to the router from remotely by telnet, SSH. That is a part of the management interface, and based on that you can just do everything. So this is how your legacy system is working. Means if you have the thousands of router, then you have thousands of brains, means control plane, or thousands of data plane, means every data plane, every control plane are going to be always within the box. So if you have the multiple box, multiple control plane, multiple data plane. But when I talk about the software defined networking, the game is going to be totally changed. Software defined networking game is going to be totally changed. How it is going to be changed? Let's understand. So let me clear. Any doubt, guys, before I clear? Anyone have any doubt here in this particular whiteboarding? If no doubt, I'm clearing this board. Please ask me later. Now, if I go for the SDN solution, that is known as software defined networking. First, understand what are the key component of the SDN. Then we'll understand how SDN is going to be process the packet, same packet. So SDN having a three component. One is known as the SD-WAN. Okay. Second is known as the SD-LAN. That is known as the SD access. Okay. Third is known as the, you can just talk about SD data center, which is known as the ACI. This is known as the application centric infrastructure. Let me write it here. Application centric infrastructure. SD access, SD-WAN, access, SDX software defined access means you're basically switching environment. That is a LAN environment. Okay, SD-WAN is software defined WAN, means wide area network. So in SDN, we have a three component across the all departments. Means when you're going to build any network, you require the WAN network, you require the LAN network, you require data center. Only we have a three provisions, not more than that. So WAN is going to make the connectivity from one location to another location. We know that earlier also, means you have the multiple building within the different cities and you want to make them communicate. Then you require the WAN. Without WAN, you cannot make the communications. So WAN is definitely going to be required. LAN is going to be, let's suppose within a building, you have the multiple floors and they all want to communicate within the all building, premises, within the home, within the office. So LAN is going to be there, and LAN is going to make the communication throughout this building or location. Data center, let's suppose you have the big data centers and you want to make the communications. So data center is going to be connect your servers, your firewalls, your load balancers, your routers, your different devices, and based on that, basically you can go and communicate with your data center devices. So these three components is going to make complete your network infrastructure. This is going to build the network infra. Which network infra? Software defined network infra, SD network infra. And we have to understand all these three components. So let's focus on first SD-WAN, right? Then we come and discuss about the SD-LAN. Later we discuss about the ACI as well, how ACI is going to work. Because in our modules, we have to understand in these sections what is the SD-WAN and what is the SD-LAN. Okay, you can see SD access is basically SD-LAN. So first focus on the SD-WAN, then we'll talk about the SD-LAN as well. So in SD-WAN or SD access or SD-LAN, the concept is going to be same. Means earlier we have a routers like this one, and also we have a switch like this one. This is my switch. This is known as a traditional router, or we can just make a switch. It's a traditional way of doing the routing and switching. That having inside everything means you have the control plane, you have the data plane, and you have the management plane inside of the box. Means everything you have the box. Now, when we go for the SDN solution, then what is going to happen? Your data plane is going to be in one place. Okay. Means this, think about this is my R1 router, this is my R2 router, this is my R3 router. These are going to act as my data plane. But my control plane is going to be in different location. This is my control plane, where we are going to put all routing engines from my routers. Means these routers are going to be brainless router. Okay, brainless router means these routers doesn't having any brain, and our brains are going to put in the some central location. It could be your data center, your on-premises data center. Might be you can put on the Azure, AWS, GCP, private public data center, anywhere you want to put that. But whenever you're going to define the SDN solution, your router is going to become a dummy devices. They only will give the physical connectivity. Means let's take an example. Let me clear this particular and I can explain in a better way. So let's think about, I have the location in New Jersey, USA. Okay, this is my data center. I put my all brain here. Means brain are here. Just think about, these are my brain. And this is my router. This is my R1. This is my R2. Okay. Now take an example, same scenario, which discussed earlier. We have one of the device connected here, which having this particular IP address /24. This device also connected here, that having IP address 16.16.10.10/24. If these two devices want to communicate, so again the packet is going to be built here. There is a source IP address. There is a destination IP address. What is my source IP address? This is going to be 10.10.10.10. Destination is going to be 172.16.10.10. This is your IP packet. IPv4 packet. The moment your interface, this is my, let's suppose G0x0 interface connected here. Here also G0x0 interface connected here. These two different router. Now, if this packet want to talk to this packet, this IP, means this particular IP, your packet is going to point to the router, but router is basically your brainless router. Do not have brain. It's a brainless router. Means They not have the routing table. This router also no routing table. So how they're going to make a decisions? How I send the packet to this particular location? In that case, they need to communicate with the controller. Controllers are basically your control plane devices. So your controllers are going to be set in somewhere the remote location. So they have to communicate with the controllers who maintain your all routing table. The local box is not going to maintain any routing table. You must have to communicate. But how? How they're going to communicate? For that, you require the service providers. Means ISP. Might be you think about the AT&T. You just think about the Verizons. You just think about the Airtel in India. You can just think about the Vodafone, VI. So you have to make the communications to the controller like this one. And from there, they are going to build a secure tunnels. Means once you're going to learn the SD-WAN in very detail, you're going to understand these controllers are going to build a very secure tunnel with the routers. Okay. And based on that secure tunnel, they are going to exchange the routing tables. Means if they want to communicate from there to there, they first talk to their brain. Hey brain, can you just tell me how I can reach to destination? Instead of local brain. Then it's going to, okay, that's fine. You want to talk, then you can just go via this path and they will go to communicate. So this is how your SDN network is going to work. Means any SDN network, either it's SD access, SD-WAN, and SD like data centers. In all scenario, your brain is central place is going to act as one of the main functional point, main think pad, where every information means if you want to do any configuration even, you cannot do local device configuration. You can do the config from here. You can do the T-shoot from the central locations. You can do any routing update also from the central location. So means all performance means all whatever network performance you want to do that is going to happen via the central locations. This is how high level SDN is going to be work. Is it clear? Everyone, any doubt? Please come on guys. If any doubt, please let me know. Okay, then is it clear? What are clear? Amrita, you understand? I believe we discussed this all in the SD-WAN, so you
Yes,
know
sir.
about this, right?
Yes, sir.
So basically, it's a very different design in the legacy one. So everything means data plane is going to be separated. This is known as your data plane, where your router is going to be connect. And when you're going to connect your any controller, that is known as the control plane. And in this plane also we have the management plane. Why management plane? Because you managing the config and all. So if you go in the architecture of the SDN, you can see this is a slide of the SDN, and you can see SD-WAN when you go to start and learning about the SDN. So SDN, we have to understand where it's coming from, solution architect, and by software features, scratch the surface, and learn more about it. So you can see why SD-WAN. So earlier when we have the legacy design, we are basically going to communicate from branch to hub locations, and from hub we have the any kind of the cloud application reachability. Either you are going for the Salesforce, Webex, Office 365, Azure, AWS, private cloud, public cloud. So you are doing the black holing everything via your central data centers. If this is going to be down, then you're going to be lose all kind of the connectivity. And not only this going to be down, also when you're going to data center for the all application access, let's take an example. You are in Delhi, an application in Delhi itself, but your data center in the USA. So you going first USA and then coming back to Delhi to access the application, which is already in Delhi. And you are also in Delhi, but because your design is saying I have to go data center, then I have to come to my applications. There's OCC 5, which is in Delhi. That is not good design. It is going to add latency of your network. So how we can mitigate this problem? So legacy design was hardware-based design was like of yesterday design, means it's old design, means everything branch to branch communication was happening from data center. Branch to public cloud, private cloud is happening via data center. Internet breakout happening on data centers. So every bottleneck is going to happen by data center. If data center having any issues, you are going to be absolutely going to be, service disruption is going to happen for your network. So to mitigate this problem, that Cisco SD-WAN come in a picture where you are going to be design a flat network where you don't have any dependency on data centers for any connectivity. It's a cloud connectivity, data center connectivity, direct internet connectivity. Every branch is having their independent connectivity. And if something is not good from the branch point of view, that is only those branches going to be impacted instead of the all branch is going to be. In previous case, if something is not good in data center, my all branch and cloud application is going to be impacted. It's going to be critical situation for me. But now if I have the different approach where I have the flat network, means everyone is doing their own decisions and they are actually helping to build a network in such way that is in case of anything is going to be down, still I can reach to my applications, my destination without any problem. That is a software defined approach. And in this case, you can see you can do any kind of deployment. Means if you want to deploy the SD-WAN solutions in your on-premises network, you can do that. Cloud, you can do that. Multi-tenant, you can do that. Automation, you can do that. Network insights, you can get. Machine learning, AI, you can do programmable, scalable, any services it's going to be support. Multi-cloud integrations, multi-layer security they can give. Even this SD-WAN routers coming with the solutions, that's the next generation of firewall solution. So in case of the any issues is going to be happen, you don't have to purchase other additional firewall for the security point of view. You want to secure network for URL filtering, IPS means UTM, like Unified Threat Management. If you want to integrate, that is also possible. SSL decryption, TLS decryptions. You want to do the application identification, file checking, CASB integrations. Everything is possible. Means analytics, they will give that voice services, multi-domain, intent-based networking, IBN policy, any transport. Transport is your ISP. Even you want to build the connectivity for the SDN sites for the one site to another site, you don't have to depend on I need only MPLS, I need only internet. No. You can use any transport, satellite, internet, MPLS, 5G, LTE, like SDCI, that is a software defined cloud interconnect. Means one data center of the any Azure want to communicate to another data center of Azure. So they use their software defined cloud interconnect kind of circuits. So that is going to give the kind of the ISP environment. Or most important, any locations, as I mentioned that you don't have to be always dependent on a certain location to go any kind of the application reachability. You're sitting in the India, sitting in the remote site, and you have the site is the SDN site, SDN branch, you can just communicate any of the application without any issue. This is how you can build the communications with the all communication, means all kind of the requirement. So SDN is going to give a flavor. Its network is going to very much flexible. And those flexibility is basically going to help you in terms of the any kind of the redundancy, any kind of the single point of failure if you want to avoid, that is going to give. And trust me guys, let me show another slide. If I talk about the legacy WAN, we having a lot of challenges with the legacy WAN. Let me show you. So if I talk about the benefits of the SD-WAN, benefits of the SD-WAN is going to happen. It is going to improve your performance. That is the one thing. Boost your security means, as I mentioned that this SDN is coming with the integrated security features. Means earlier router doesn't have the security modules. If you want to do the next generation of firewall feature, you cannot do that. But this SDN is going to give the next generation security as well. Means your firewall feature is going to be integrated, and based on that firewall features, you can just do any kind of the firewall filtering, next generation firewall communications. You want to do that, apply that. That's all possible. The design is going to lower down your complexity. Means overall, the design of the SD-WAN is going to lower down your complexity. What does mean? That means, let's suppose you have any kind of the configuration errors, any kind of the troubleshooting you want to do that. Earlier, you have to do manual search on the CLI basis, whether my link is down, any error I'm getting. But in the SD-WAN, you can easily get the GUI based output. In case of the any kind of the error, let me see if give me 1 second guys, let me switch my network. Hold on. Okay, so let me see if my SDN is on. Okay, so see, this is my 𝗕manage. Okay, so I'm just showing you the idea how it is going to be look like. So you guys see here, this having the firewall feature, as I mentioned, that means you can just do everything like firewall, intrusion preventions, URL filtering, advanced malware protections, DNS security, SL and TLS inspections, means everything you can do that. And you want to do troubleshooting. See, every health is showing on in front of you. Means how many control connections are down. Probably 2 p.m. you have the SD-WAN batch. So if you guys want to learn more about the SD-WAN, so you have to learn SD-WAN in the SD-WAN batch itself. We are going to be till 30-40 hours session for the SD-WAN, where we are going to do a deep dive of the SD-WAN. But for CCNP level, you should have the basic fundamental knowledge, like how SDN is going to work. So I want to just compare that. If I have to do the legacy router troubleshooting, then I have to go and run every command. What is my link utilizations, whether my link is up and down or not. But here you don't have to do anything. In front of you, everything available. And you want to see more detail, just go here and run the real time. And you can see you're going to get what is my WAN throughput. You can see you want to see what is my applications, deep packet inspection. What are all applications my WAN is recognizing? Any kind of the we have the QoS configurations, any kind of the interface having error and all. So you can want to see the top talker result. You can get the top talker result. You want to see what all flow is going on. You want to see the firewall security data. You can just do that. Even you want to do the troubleshooting, ping, trace, control connection, device bring up. So these different features available with us. You can do lot of things which was not available in the legacy WAN solutions. So in short, if I talk about the SDN solutions, SDN is going to give these all key benefits. Improve performance of entire your SD-WAN, means your WAN solutions. It is going to integrate security. Your complexity is going to be lower down. You can connect the cloud easily. You don't have to be dependent on the data centers. You can reduce the cost definitely. If you have, take an example, if you have the 5 routers or 500 routers and you have to do the iOS upgradations, you have to go and do a lot of work to do iOS upgradations. You have to copy the iOS image in the routers. You have to align the engineer. You have to take the downtime. You have to make the repository. But in case of the SD-WAN solutions, you just go and click. Let me show you. If you want to do the 500 iOS upgradation, just select all 500. Right now, 4 devices are down. I need to restart. So all 500 is going to be there. List all selected and click in the upgrade in one go, and they are going to be upgraded. Think about it. So your life is going to be very much easy. Your life is going to very much easy with the SD-WAN solutions. Means it's going to be give the intent-based networking. Yes, Amrita?
Sir, during the SD-WAN upgradation, it will follow the queue pattern or simultaneously it will update to all the devices?
Simultaneously, individual router is going to be updated. There is no queue pattern. If you click 2 routers at the same time, both are start doing upgradation at the same time. There is no queue pattern is going to follow.
Okay, but in my last SD-WAN upgradations, it follows queue. That's why I'm asking.
Which version it was?
17.12.5D. Cisco 8000 series 8200 and 8300 managed device.
Okay, it was CS router, not a VH router, right?
Yes.
Okay, I will check for that particular version. And you are upgrading for the vManage directly, right?
Yes.
Okay, I will check for that. Okay, no worry.
Okay.
Thank you.
Okay.
I will take note and I'll check this one. I will just try to simulate this one.
Okay.
So,
Okay. Thank you.
definitely. So you can just go and click a single. Might be some versions they have upgraded, but we'll check that and it is going to perform. Generally in production, what we do that we not go and do the 100 of the router in one go upgrade, but we do 5, we do 10, 15, 20, like a small chunk. Basically, we do that, and based on that, it is going to be just upgrade your all iOS version. Also, intent-based networking, that is it's going to give the flexibility right? It's going to give the flexibility where whatever you want, based on your want, you can just do the networking. Means I want to send the traffic some one link, I want to send some traffic another link, I can do that. Also, it supports the in application aware routing, predictable application experience. What is application aware routing and predictable application experience? Predictable application experience, that means you already know what all applications are running on my WAN interfaces, how much utilizations we are using on that particular applications. So accordingly, you can plan for downgrade and upgrade of your applications. If you want to downgrade, you can downgrade. If you want to upgrade, you can upgrade that one. There is no problem. But even you want to do the application aware routing. Application aware routing, that means generally we do routing based on the IP address. Means we have the source IP address, destination IP address, and 99.9% case we do routing on the destination IP address. Because if we are not going to use the PVR, always routing happen via the destination IP address. If I'm going to use a policy-based routing, in that situation we can do the routing based on the source and destination both. That is absolutely possible. But what is the application aware routing? Application aware routing is routing where based on the Facebook application you want to do routing. Means let's suppose I have two links. This is my R1 and this is my R2. This is my internet ISP. These are connected in this way. I have the LAN here. My user are sitting here and he want to send some Facebook traffic. I want to send via this link. I want to send Instagram traffic. I want to send via this link. I want to send some kind of the YouTube traffic. I can send via this one. I want to say WhatsApp traffic. I can send. This is the application aware routing. Means based on the application, you can do the routings. SSS traffic you want to send, you can send here. You want to send telnet traffic, you can send from here. You want to send HTTPS traffic, send from here. HTTP, HTTPS, you can send from here. So whatever you want to do the application, not dependent on the any destination, even you can send that. And also most important is perform zero touch provisioning and zero trust fabric. Zero touch provisioning means without doing any configurations of the local router, still it is going to be on board. Means without doing any configuration. Let's suppose you purchase any new router and going to connect in the rack, connect the WAN cable, connect the LAN cable, and it is going to be automatic onboarded on the system after doing the power on. How it is possible? How this magic is going to happen? You're not doing any single line of the configuration. That all possible with the help of the SD-WAN solutions. Zero trust fabric means anything you are doing that in the fabric, it is going to be zero trust. Means it is never going to trust to anyone. Always going to verify your identity. Means let's suppose you want to onboard any router, any switch, any kind of means not switch, basically router and controllers. It is going to verify your identity. Are you really belong to me? Are you really legitimate to me? If you are not legitimate to me, you are not going to join my fabric. So that zero trust fabric. This is the key benefits of the SD-WAN solutions. And challenges of the legacy WAN was this one. Means if I talk about challenge of your legacy WAN, means cost was very high. You cannot scale the network in very large scale. No cloud readiness means cloud integration readiness, fragmented security, limited application awareness, insufficient bandwidth, disjoint solutions, complex operations. Means you can think about if I am going to use the legacy WAN, we have a lot of challenges. Means cost is very high. Complex operations, you have to hire a lot of people to manage those operations. Troubleshooting is going to take a lot of time for you. Disjoint solutions means solutions are not very standard for the everywhere. Means somewhere you're using some different designs, some other way you're using some different design, and you're integrating that, adding the more complexity. Bandwidth are not going to be very sufficient. Always you have to be integrate some new kind of the ISP to just meet your all bandwidth requirement. Sometimes it's going to be sitting idle, not using the effective bandwidth because you don't have the scenario. You can use the application aware routing. You might be going to use the active passive solutions. In that case, one router is completely going to sit in idle. You're not sending any traffic. In case of the active, you're sending all traffic with the active. If you want to do the load balancing in active passive, then you have to do a lot of configuration manual. It's going to add additional complexity. So application awareness was not there. So by using this all challenges, SDN come where they solve these all challenges. and give the very good platform where you just, get that very good infrastructure to just run your WAN operations. So that's why you can see we understand working principle of the SD-WAN solutions, control plane, data plane element. So now we understand about the problems, right? We understand about the solutions. We understand about the key benefits of the SDNs, right? But we have to understand what are the devices available in the SD-WAN solutions. So if you are going to deploy the SD-WAN solutions, we have the multiple devices. Go here. Means in SD-WAN, we have the multiple devices. You are going to find as a 𝗕manage, 𝗕analytics, 𝗕bond, 𝗕smart, right? Also, this is going to replace as a manager because we are targeting the catalyst SD-WAN. So you might be confused about what is the catalyst SD-WAN. Okay, let me write it here. There was Cisco SD-WAN, 3 SD-WAN is there, 𝗵𝗶𝗃 SD-WAN, versus Cisco SD-WAN, and versus third one is the catalyst SD-WAN. Okay, if I say all are same, don't be confused. 𝗵𝗶𝗃 was the company who designed a very good SD-WAN solution. Cisco purchased that particular company. Okay, Cisco purchased that company, then it's become a Cisco SD-WAN. Now, recently in 2022, Cisco rebrand their product as a Catalyst SD-WAN. So that is the Catalyst SD-WAN, but they all are same. There is no much difference. Only the rebranding has been happened. So they having a controllers that is known as the earlier 𝗕manage. Now it's become a manager. In the Catalyst SD-WAN become a manager. They have another device which is known as the 𝗕bond, and this is known as the validator. Third, we have the 𝗕smart, that is known as the controller. And last but not least, they have the 𝗵𝗗 and 𝗕h router. This is known as the 𝗵𝗏 now. So this is a new name. If you're going to learn in the SD-WAN, in the Catalyst SD-WAN, so your 𝗕manage is going to known as the manager. Okay. 𝗕bond is known as the validator. 𝗕smart is known as a controller. Okay. So, and this is the 𝗵𝗏. This is your routers. Give me 1 second, guys. One second. Give me 1 second. So this is going to be your 𝗕h and 𝗕h, and this is known as actually your routers. This is the routers, and these routers are basically going to be brainless router. Means and who is going to manage the brain? This is the brain of routing table. This controller is going to be maintaining all brain, right? Means routing table is going to be there in the 𝗕smart. These routers are always going to take a routing table from the 𝗕smart. This validator is going to use for the authentication. Okay. This is going to be for all config, tshoot, and etc. Other things also we can do that. So you can see there are the multiple devices in this particular diagram. 𝗕manage is manager. All configuration you can do from the 𝗕manager. 𝗕bond is going to use for the authentication. Means any device you want to onboard, this is going to use for the authentication. 𝗕smart is going to be your brain nervous system or routing table. So this is going to maintain your routing table. So any edge want to take the routing decisions, they will consult with the vSmart. So these are the elements. So these elements basically in upper element, these are known as your control plane. Let me write here. Control plane elements, right? And the below one, let me use different color. This basically is known as your data plane. Clear? So in SD-WAN, what is my control plane? Control plane is my vManage, that is a manager. vBond is the validator. vSmart is the controller. Same name, just same thing. Name has been changed only. So you just remember all the things. Data plane, if I'm just talking about the C edge, V edge, that is going to be your routers, right? And that is a WAN edge. This is going to be, it is going to be used to just connect your all the connectivity. So let me show another PPT so you can recognize that. So I discussed about this one. vManage, vNetix, vBond, vSmart. These are going to be your old name. New name is going to be Catalyst Manager, Analytics, Validator, Controllers. But if we talk about this control plane, this is your control plane. This all is known as your control plane. Means whatever you see that, this is the control plane and this is your data plane. You can see this is the control plane. Means you have the management plane also. Why management plane? Because the device we manage is known as the management plane. And orchestration plane is the bond is going to be known as that is a validator who just going to manage and orchestrate your all fabric. All right. So in high level, you should know about these all things. So I hope you guys at least understand these sections very clearly. Any doubt? Why SD-WAN? What is the benefits of the SD-WAN? What is my control plane? What is my data plane? Limitations of the SD-WANs means benefits and limitation of the SD-WAN or the WAN which we discuss. Any question, guys, here? I hope we are good till here. Shall we move next? Okay. Now, similarly, we have to understand SD access now. So give me 1 second. Let me find the SD access slide, one of the SD access slide. Give me 1 second. Let me open another slide for the SD access. So at least you guys will understand step by step everything. Okay. So as I mentioned that SD-WAN and SD access. SD-WAN is going to simplify your WAN solutions. But SD access is going to simplify your all LAN solutions. If you want to make your LAN as a very, intelligent, you want to make your LAN as a very, software defined based LAN, means your decision is going to happen based on the intelligence of the policies, intelligence of the central management. Then you can deploy this SD access. And this SD access also have the control plane and data plane element. You can see SD-WAN also the control plane, data plane, and they also traditional campus interoperating with the SD access. Means if you have the legacy router switches, you want to operate with the SDN solutions with the SD access, how you can do that? So this is what we have to understand, right? So SD access is something that is going to for the LAN automation, LAN infrastructure. So you can see this is a very big discussion for the SD access. So I'm not going to talk each and everything, but I will try to give the high level idea so you guys will understand. Let me see. You can see we have the controllers. So let me talk about the controllers. See, if you talk about the SD-WAN, What is the controller from where you can manage? That is known as the vManage, or you can just known as the manager. If you talk about the SD access, SD LAN, there is a control that is the DNAC. Okay. And if you go for the SDDC, that is a ACI. There is a controller that is known as the APIC. Means any configuration you're doing or troubleshooting you want to do for the SD-WAN, you have to always do by the vManage. This kind of dashboard, you can see this dashboard. This is your vManage. From there, you can do all kind of the configuration. But SD access, it is going to be, right now I don't have, but this is going to give that kind of the dashboard. This kind of dashboard, you can see. This is a SD access dashboard. So similar to the SD-WAN only. But by sitting, you can just visualize what is happening in my network, how my network is performing, how my data is going on, how many AP are connected, how many AP are disconnected, how many WLC are connected. Because LAN is AP, WLC, client, printers, every devices. Generally, we manage WLC, client, and the access point. So this is going to give that. And if you go for the APIC dashboard, that is your data center. See, this is your APIC dashboard. This probably I have access. This APIC dashboard I have access. I will show later on. But oh, where it's gone? So you go here and you just go in the image. See, this is your APIC dashboard. Means ACI, once you log in, now you're going to get this kind of the APIC is coming as a YouTube. So you're going to get the image as a APIC dashboard like this one. Let me show you. See the APIC dashboard. So by sitting on this Cisco APIC, you're going to visualize how my data center switches are connected, how my leaf spine is connected, how we are building the connectivity, and how my L3 out gateway is connected. So this is how you're going to get the APIC dashboard and all. So every controllers there have their DOS dashboard. So we manage for the SD-WAN, SDX as a DNAC. I hope you understand this one. Now, if I go again here and I try to explain about these solutions, so you will understand. So you can see SDXS have the means overlay, underlay connectivity. So I'm just going to tell in the very high level because we have to understand in CCNP level about the terminology, not very detailed level. But in overlay, we are going to find the GRE, MGRE. Also in the SD-WAN also we have the overlay, underlay. Overlay is TLS channel, DTLS channel, underlay is basic IP reachability, and OMP also going to be there. Similar way, in that particular GRE, MGRE, MPLS, L3VPN, IPsec, DMVPN, CAP-web, example here, LIPS, OTP. These are the overlay examples. So SDXS also use the overlay connectivity with the help of the different kind of the protocols. And the underlay is basically your IP reachability, right? So whenever you're going to deploy the any SDN solutions, so what is going to happen? This is your fabric is going to build. So your control plane is going to be your controllers, whatever the controllers you are going to integrate. Like you have the Cisco DNS center where you're going to be automate your all kind of the configuration, right? You can do the network automations. You can see network automations, network assurance, identity services. These are the control planes. Means there are devices. Your IS is going to be there, right? IS is also going to be there. Data collections is going to be happen, right? That is the NDP. Analyze the endpoint app flow and monitor the fabric status. Means everything from the endpoint point of view is NDF engine is going to be there. This is going to be your automation. Means simple graphical automations. Means anything you want to build, policy you want to create, troubleshooting you want to do that all is going to happen from this particular your NPS, right? And also this is the identity services. IS is going to be everything is going to means you know that if you want to authenticate any devices, you want to log in any devices, IS is going to maintain all the record, right? Everything is going to be there. And now you can see, now you see control plane nodes. Control plane nodes are basically is a node who is going to manage your all control informations, right? Means map system that manage the endpoint devices and relationship. Means controllers are basically, it's going to be responsible to build all the relationship between the different kind of the devices. Fabric border node, where you just integrate your fabric edge node and your controllers. That is your fabric border node. Border node is going to act as a broker. Means if I want to communicate with my controllers and the fabric edge, that is my border node is going to be there. And that edge node are basically actually your data planes where you are going to connect your endpoints. You can see these are the endpoints where you're going to connect everything on these particular locations. So data plane, that's the end devices. This is the border is going to be intermediate devices who connecting to the event controllers. Means let's suppose WLC you have, that is also part of the controllers. If you're running the any WLAN solutions, Wi-Fi solutions, how we can communicate with them? So this is going to make the connectivity with them. And if you want to go in deep dive, right, you can see control plane node. See, so control plane node runs a host tracking database to map location information. Means any kind of the host, any kind of the access point, any devices who are part of the fabric, it is going to maintain their database and location informations. A simple host database mapped with the endpoint ID and the current location along with the other attributes. There are a lot of attributes, and also the database support with a multiple type of the ID lookup like IP address, IPv4, IPv6 and the MAC address. And also they know that endpoint map registrations from the border node. So you just think about control plane node are just your brain nervous system who maintain your all database, right? Based on the database can be your IPv4, IPv6 and a MAC address. Data plane is just going to be your switches. Means these are the high-end switches who have the control plane information, but data plane is let me go here. End node is going to be your data plane. These are the end plane node which is going to be connected to your data plane devices. Let me find internal. There is a data plane also. Virtual network. It's a very big, like different concept they have. I don't want to talk these all. Okay. So see, there are LIPS protocol they're running. There are LIPS map resolver, and that is a control plane. You can see any kind of the your LIPS. We'll discuss this one in very detail later on. You can see this topic we'll discuss in very detail. I will explain what is the LIPS protocol later on, right? But they use the protocol which is maintain that all kind of the your mapping. That mapping is going to help to forward the packet. That is the LIPS protocols. So I will explain that maintain the endpoint identifier, routing locator, and that's going to be connected fabric. So your data is going to connect here. You can see database mapping means any packet is going to punt here. They want to communicate to other LIPS sites. So the LIPS is going to be basically help as a control plane information, means control plane routing, but data is actually from where the actual packet has been originated. So one more diagram I'm just searching. Let me see if this one having or not. It's a very detailed one. Okay, so you can see this is a DNA controller, automation, assurance, and identity policy, and this is the campus fabric where actually your end user are going to be connected. Means actual site location switches where actual end user is going to be connected. And let me see if this slide having that information. Because okay, so you can see what is SDXS. So you can see this is a GUI approach to automation, assurance of all fabric configuration management grid in the policy base. Simple. SDXS is nothing. It's just a way of automating your LAN infrastructure by creating the centralized policy, and you can manage those policy, automate the task. Cisco DNS Center integrated to the multiple management system, orchestrates LAN wireless, right? Orchestrates LAN, wireless LAN, and WAN access. Means we can integrate this Cisco DNS Center with your campus fabric, and these are your data planes. These are your control planes, and campus fabric CLI or API approach, but build the LIPS and VXLAN and common spanning tree CTS fabric overlay for the enterprise campus network. So they are going to be integrated with the LIPS protocol, VXLAN, and then also CTS fabric to overlay, and CLI provide the backbone capabilities. So box to box, they are going to run the netconf and the YANG, and they are again, this is the overlay concept. And this is the how we discussed earlier. So they are data plane, these are the control plane nodes. You can see control plane nodes, they are again controllers, and they are the actually fabric edge node are going to access the data plane nodes. So you should know like what is my data plane, what is my control plane. So data plane is going to be your switch edge. What switches? High-end switches. Like this one is your switches is going to be there. Also you can deploy this switches in the control planes, but they have different switches. They are going to act as a data plane. This fabric node is going to be bigger switches. Access node are going to be a small switches like Catalyst 9300, 94,000, right? Endpoint again going to connect your any kind of the connectivity for the end users like L3 gateway, you want to do that, static 802.1x active directly integration, you want to do that. That all possible you can do from the SD access. So what I want to say that I want to say if you want to just integrate any kind of the SD access, you have the control plane, that is your controllers, TNAC controller, IS we have, NDP we have, and then we can just have the border node, and then we have the edge node. Edge node is going to be integrate as a your basically data plane where you connect your printers, access point, your any kind of other computer devices. So this is how you can understand. And if you just want to Google even that particular things, you are going to find the similar kind of the solutions on the Google as well. You go in the image and see this is your fabric. So again, DNS center, policy, automation, also assurance, everything you do for the controller point of view. Fabric node, control plane, that's going to be fabric border is going to be kind of the broker between the controllers and your data plane. This is the employee network, IoT network, where actual user is going to sit. So this is going to act as your data plane, and based on that data plane, you're going to communicate. And this diagram also you want to refer. Software defined access. It's going to give the deep visibility of the endpoint, map their integrations, define access policies, group-based policies, segmentations, policy consistency throughout, means everything policy you want to do that is going to happen for your this particular SD access controllers. But data plane is again your end router. Any questions, guys, till here? Any questions about this architecture concept, SD-WAN, SD access? Battalion, you understand? Amrita, any question? Akash, Vikas, Himai, Sheikh, Sridhar. I know a little bit lengthy topic, theory topic, but next onward is going to be interesting. But I hope you guys understand. Okay, now we have to, let me stop this recording.